Hello there, welcome back to P.O.D officials. And in our last lesson we talked about Pythagoras theorem, and we are still on it. So today we are doing two examples on that, and I would want you to follow. Before then, make sure you subscribe, you share, and you also comment. Okay, so let's proceed. In our first question, it said find line PQ in the diagram. So this is our diagram. This is P, Q, and this is R. And so we are finding line PQ. Looking at the way the diagram is, it means that our angle will be here, and our right angle will be here. So if that is the case, it means that these are hypotenuse, these are opposite, and these are adjacent. Okay, so it means that we are looking for our adjacent in the first question. And this is how we go about it. We will pick this line, that's our hypotenuse, that's line PR squared will be equal to our opposite, which is QR squared, plus our adjacent, which is line PQ, that one 2 squared. Now, PR is 13 meters. So, as I said previously, for the sake of our solvings, let's omit the units. Afterwards, we bring it in our final answer. So 13 squared is equal to QR is 5, so 5 squared plus, we don't know our PQ, so with that one we maintain it. Okay, so 13 squared is 169. So 13 squared is like 13 times 30. Using the vertical mathematics way, you can get it. Okay, pause. Now 5 squared is 25. 5 times 5, which is 25, plus line PQ squared. Now we group like terms. Grouping like terms means that all the numbers goes to one side and the variables come to one side. For the sake of time, I would want our line to be here. So we have line PQ squared, which is equal to, now if this one is here, it's like I've turned it like that. So this one I've come here. So our next value is 169. Now this one was here and I turned it like that. So this one is crossing the equal to sign. It becomes minus 25. So we have PQ squared is equal to, now 169 minus 25. We have 9 minus 5 is 4. Now 6 minus this 2 is 4. So we have 1. So we have 144. Okay. Now having 144. In our previous lesson, I told you that if you want to take square from there, you have to take square root of both sides. So we take square root of both sides. So we have line PQ is equal to, now watch here. If you have a number in the square root and you want to omit the square root, you check whether that number is a square number. A square number is a number that when you square another number, you will get it. So with this one, you can see that 12 times 12, which is 12 squared, is giving you what? 144. So we have square root of 12 times 12. Now when we proceed and we come down, the same thing can be 12 squared, because 12 times 12 is 12 what? Squared. Which the square root can cancel the square root can cancel the square, leaving 12. Now we have line PQ to be 12, and the unit, mind you, the unit is meters, not centimeters, so 12 meters. So therefore, or it implies that line PQ is 12 meters. That's it. Question 2. With that one, is a find line DF in the diagram. So here's our point D, this is our point F, and this is E, and that's our line. So with this diagram, we can see our angle is this one, and our right angle triangle, our right angle is also this one. Now They say find df, and here we are fortunate they represent df like df with a variable which is x. So we can use the x without using the df. In all, at the end of the day, we arrive at the same answer. But for the sake of the formula, we have our hypotenuse to be fe. So line fe squared is equal to line df squared plus line de squared. Now, our line fe is 15 meters. So for the sake of solving, we omit the units. Later on we bring it. Now 15 squared. Now df we don't know, but we know our df is x, so we become x squared. Now de is 12, so plus 12 squared. Now 15 squared is the same as 15 times what? 15. 5 is 25. 5 carry 2. 5 1 5 plus this 7. Now 5 1 5, and we have 1 times 1. We add it 5. This plus this is 12. 1 2 2 2. So we have 2 2 5. Now our x squared is still x squared because it's a variable. Now 12 squared is the same as 12 times 12, which is 144. For the sake of time, I don't want to solve that one, so we just do it straightforward. Now we just want to regroup like terms. Grouping like terms I've already explained in this same video, in the previous question, that we group like terms, variables go to one side, numbers come to one side. In this sense, I would want to bring this variable here. So it's like I'm turning this upside down. So we have x squared plus 144 equals to 20. 225. It's like I've brought this here and I've brought that one here. It's the same thing in mathematics. So now we are grouping like that, and this number moves to the other side. So we have x squared is equal to 225 minus, it's positive, it's crossing the equal to sign, becomes minus. So 144. We have x squared is equal to now 225 minus 144. 5 minus 4 is 1. This minus this is not possible. You borrow 1 and add it to this, it becomes 12. 12 minus 4 is 8. Now we have 1 left here. 1 minus 1 is 0. We don't write it. So we have 81 here. Now where we got into might be a bit confusing to some of you. As usual, we take square root of both sides. So the square will take the square root from there, leaving only x for us. Now with this one, 81, you then look for a random number. When you square, you get 81. Like the previous one, as I did for the 12. So with this one, when you recite even the timetable, you get it. 9 times 9 is what? 81. 9 is 81. So we have square root of 9 times 9, which is the same as square root of 9 squared. Because 9 times 9 meaning the 9 are 2, so squared. The square will cancel the square root. Now x is equal to 9. Don't forget the unit. The unit is meters, so meters. You get it? So therefore, or it implies that, so this one is therefore, it implies means this one. So therefore, x is equal to line DF, which is as well equal to 9m, and that's our final answer. In the same way, I would urge you to subscribe, share, like, and also comment. So your comments are more important. When you comment on it, then we will be able to improve on our lessons. Thank you.